Hello everyone, we are Sarah, Kenny, and Stephanie of group number 25, and together we conducted our research project on the topic of gamification in education. Our research topic is the gamification of educational applications and its effects on cognitive learning. For those who aren't familiar with the term, gamification is the application of game mechanics to non-game environments. You've probably witnessed gamification in effect many times before but never really noticed it. For example, Starbucks used gamification tactics to enhance the customer experience and boost sales through their Starbucks Rewards application. Customers would register for My Rewards through an app. Every time they purchase a Starbucks product, they accumulate stars in the shape of coffee cups. There are 3 levels, depending on the degree of user loyalty. More frequent visits to Starbucks are awarded through an upgraded level, and benefits include an extra cup of coffee, a birthday gift, or even offers designed specially for the customer. Another example is Foursquare. This social networking phone app rewards users for checking in on their travels. Similarly to Game, users receive points and badges based on the location they check in at and the frequency of their visits, encouraging them to keep using the app. These are just a few examples of using gamification in non-game environments to encourage user behaviors. For our project, we examined the use of gaming elements in educational platforms and applications to see how it affected student learning. Our goal was to find out whether gamification can increase user engagement and learning in educational settings. We found that by using game-like techniques such as scoreboards, badges, trophies, feedback, and rewards, users tend to feel more ownership and purpose when engaging with a task. What's interesting is that the psychological effects of gamification may actually end up being very beneficial to students in the long run, as studies have shown improved performance in various subjects. If we can figure out what gamification methods work best and how to properly implement them in the classroom or e-learning environment, education could be changed for the better. I'll now go over a few of the articles that we use to further explore our topic of gamification in the educational setting. In the first article, called Gamifying Learning Experiences, Practical Implications and Outcomes, the researchers created a plugin for the e-learning platform Blackboard that integrated rewards and gaming elements into several actual college courses. The purpose of the study was to prove whether gamification could be used in web-based education as a tool to increase student motivation and engagement. The course had optional exercises designed to improve the skills of students so that they could perform better on final exams. It included several challenge achievements from which students received trophies and medals after completion. The results of the study show that students who completed the gamified experience obtained better scores in practical assignments and an overall score, but these students performed poorly on written assignments and participated less on class activities, although their initial motivation was higher. However, there were also some students who showed low participation or refused to participate because they found it too time-consuming. The researchers concluded that the activities may not have been engaging enough for all students. Based on this study, gamification in e-learning platforms seems to have the potential to increase student motivation, but it's not trivial to achieve that effect. In the second study, Paul Denny used a learning system called PeerWise, which is similar to Blackboard. In this 26-day study, Denny used a feature that allows students to author and answer multiple-choice questions. He broke over 1,000 students into 2 groups, one that would use PeerWise as is and one that would have a gamified element. The result of the study showed that 80% of students using a gamified system achieved half the 22 possible badges, and the students answered 22% more questions than the others. Denny noticed that the amount of correct answers, 69%, was the same for both groups. However, the students who used the badges liked them and enjoyed the experience. In the third article, researchers conducted a study of 281 students enrolled in a Data Structures and Algorithms course to determine the effects of achievement badges in learning environments. Specifically, the authors wanted to know if achievement badges had an effect on student behavior in terms of time management, carefulness, and learning. The study showed great promise for gamification. The results showed an increase in every category of performance by those in the test group, though not all increases were statistically significant. Most notably, there was a 144% increase in the amount of students who submitted mistake-free assignments, a 61% increase in assignments submitted early by major students, and 33% decrease in late assignments. Though not statistically significant, the study showed test group students scored an average 3% higher on assignments than those not in the test group. Despite showing overall increases in favorable academic performances, the authors of this study also noted the potential for badges to encourage unwanted study behaviors, such as giving up carefulness in exchange for speed badges or vice versa. In the fourth article, Gender Differences in Students' Mathematics Gameplay, researchers conducted a survey of 428 primary school-aged children to assess the impact of video games on math scores. Several previous studies have shown males tend to receive higher math scores than females. This study set out to determine to what extent gender differences exist in relation to the types of mathematical thinking that are promoted in the games young children play. The study showed drastic differences in the amount of time males and females played video games on non-school days. 34% of boys spent 3 or more hours a day, while 44% of girls spent less than 1 hour a day. The study showed boys preferred to play action games such as Spyro and Medal of Honor, whereas girls preferred other games like Brain Training and Buzz. Only 4% of girls preferred the action games. Games preferred by the male students tended to involve more interpretation of maps and more general digital gameplay, games that focused on visual and spatial engagement, while girls preferred games with algorithmic computations or problem solving related to the math curriculum. Despite the fact girls tend to play more games directly involving math, males still achieved higher scores. The study concluded a need to develop more games involving visual and spatial engagement that have an appeal for girls, and that games with high visual and spatial engagement assisted in achieving higher math scores. In the article Orientation Passport Using Gamification to Engage University Students, the authors created a mobile application which utilized game achievements to creatively present orientation information for new university students to use and interact with via their smartphones. 26 first-year students were recruited to use the application at orientation and returned at the end of the day to provide feedback about their experience via the questionnaire. Their achievements were also captured electronically when they used the application. Results of the study showed that the majority of the students found the application useful for orientation. Overall, participants generally preferred game activities that required some kind of contextual input, like location, time, or an event, rather than answering questions. The majority of the students liked the interaction, scanning a QR code the most. On certain questions, students would simply guess answers through trial and error, meaning that they found this activity to be useful but not fun. All but one participant found that the achievement system added to the value of their orientation experience and that it was fun to use. The results indicated that there is a value in adding game elements to applications. However, many issues may also arise. The results allowed the researchers to determine what game elements are the most effective in non-gaming mobile application design, which elements were considered enjoyable by users, and it also showed them that strict game rules had to be applied or else the game elements would sometimes encourage undesirable use. In our last article, Effects of Game Technology on Elementary Student Learning in Mathematics, research explore how adding games to curriculum could affect students' performance in math. They performed 2 studies. The first study broke the 2 groups that used either a Game Boy math games or flashcard games for 5 weeks. After those 5 weeks, all students used Game Boy Skills Arena. On Skills Arena, students were able to choose between 3 difficulty modes, mental, extension, and place. They could also choose between addition, subtraction, or a mix. The students received immediate feedback of correct or incorrect answers and had a score tallied. In the flashcard-based game, the students used a triangular math flashcard with a partner. The questions and levels were similar to the Game Boy questions. After the first 5 weeks, the results showed that on tests, the kids who used the Game Boys had an 11% increase in scores, while flashcard-based groups had a 4% increase. What is most interesting is that the results after the next 13-week period, the students were again tested, and the group that used Game Boys the whole time had an increase in scores of 45%. However, the group that had the flashcards first increased by 47.6%. The researchers submitted 3 reasons why the all Game Boy group may have lower scores. The novelty of the game could have worn off. The amount of time of use, twice weekly, might not have been enough time to increase scores, and perhaps we're seeing a developmental peak for the 7 and 8-year-olds.
Next, we're going to discuss some future directions by exploring some studies we can do that build off the ones we already looked at. Of the studies we found, only one by Dominguez connected the participation in a gamified environment to grade performance. It did show that gamification led to an increase in scores. However, this study really focused more on participation. We'd like to see a deeper study that can correlate participation to increases of scores and grades. Using a method similar to Denny's and Dominguez's, we could create a test group that would add gamification to an online system like Blackboard, and a control group that would use Blackboard as is. By testing grades in the beginning, middle, and end, as was done in Shin, we could see if increased participation does in fact lead to higher scores. The Lowry study focused on math games versus gamification of curriculum. In this study, we learned that girls were drawn to games with social interactions and storylines, and turned off by badges, while boys were drawn to badges and turned off by storylines and social interactions. We'd like to see a study that has multiple groups and sees how different gamification systems could increase participation and or scores by gender. We propose 6 groups that could include a girl group using social storyline based approach, a girl group that uses a badge system, a boy group that uses a social storyline approach, and a boy group that uses a badge-like system, and a control boy and a control girl group that doesn't use gamification at all. Perhaps we'd find that different systems could be used based on gender or preference. And finally, while it would be logistically tough, we propose creating a multi-year study that could follow students from first grade through graduation. We can break them into 4 groups, one that uses gamification in class, one that teaches traditionally, one that uses gamification through 6th grade, and a final group that starts gamification in 6th grade. We could see if gamification continued to increase participation through the years, and if this increased grades. With the group that gets gamification that ends in 6th grade, we could see if there is an effect that continues through school even though the gamification has ended. With the last group that starts gamification in 6th grade, we could see if there's an increased participation and grades and how they relate to the other 2 gamified groups. Finally, we can use a questionnaire to see how attitudes of school and learning differ between the groups in any study. Because when it really comes down to it, gamification is a good tool and it increases scores, but we also hope that it increases a joy of learning. Thank you.